Bats and whales are two well-known groups of mammals. These two species are highly different as they vary in size, live in different environments, and hunt for different prey. However, they both share an amazing ability, the ability to navigate and hunt using sound rather than sight, or better known as echolocation. Echolocation works by the animal emitting different sound frequencies where interpretation of the reflected echoes off objects is used to build images of the surrounding. Used for foraging and communication, bats and whales are able to use the reflected sound waves from their echolocation to determine the range, size, shape, and the material of the object, which helps to determine whether it is food or not. Echolocation is known to be used by around 1,100 species of microbats and 80 species of toothed whales. Despite their contrasting morphology, both species have evolved to see with sound due to the common environmental challenge of poor visibility in dark caves for bats and poor visibility in the depths of the ocean for whales. Convergent evolution through natural selection is the result of these two highly different species sharing a similar ability. Convergent evolution is a process where distantly related species evolve similar phenotype due to the adapting in similar ecological niches. Despite the size difference, the biggest toothed whale reaching 20.5 metres, while the largest echolocating bat reaching only 16 centimetres, they both share the same frequency range. Both bats and whales can hear between 1,000 and 120,000 Hz. This is 10 times higher than that of which humans can hear, as we can only hear between 20 and 20,000 Hz. This is due to the speed sound travels in water compared to air. As water is much denser than air, sound travels 5 times faster, resulting in wavelengths to be 5 times longer. In perspective, a bat is able to detect something 10 metres away, while a whale can detect an object 100 metres away. One of the biggest similarities shared between bats and whales is the gene called prestin. Prestin is found on the outer hair cells and is responsible for the frequency in the auditory system. If arranging a phylogenetic tree based on the prestin gene, bats and whales would be grouped together despite their physical differences. The evolution of the prestin gene is responsible for the echolocation in these two species. Toothed whales produce ultrasonic clicks by passing air through a pair of phonic lips located below the blowhole. These high and low frequency clicks are transmitted through the melon in the front of their head. Once the sonar or click is generated towards an object, a reflected echo is returned to the brain for interpretation. Bats also use their larynx to create sonars. However, they also use vocal cords, which are missing from toothed whales. Bats create sonars by pushing air through their vocal cords. The rapid movement of air makes the vocal cords vibrate, which produces the clicking noise. Bats then use their large ears to receive the echoes and interpret them in the auditory cortex in the brain. To conclude, both bats and whales are two highly different species that share the same unique ability due to convergent evolution. These animals developed an amazing ability to see with sound, one which there are still many unanswered questions.